Alright guys, so now we are going to talk about the lecture 3.2, application of radian measure. With the formula, you must be able to find any variable and always express the variable you are looking for first. So I'd like to remind you the arc length, the length S of the arc, which is this right here, is defined as S equal R theta. Theta is in a radiant, so remember that theta has to be in a radiant. And so if I want to practice in this problem number 1, what do I have basically? Well, I have find the arc length intercepted by a central angle of 38.2 degrees. So basically we are dealing with something looking like this, where the angle theta right here will be 38.2 degrees. And what you're looking for is the value of the arc length. And for that, you are going to do is express S equal R multiplied by theta. Then you are going to write the fact that theta is equal 38.2 degrees. And we are going to convert right away this by multiplying 38.2 by multiplying by pi and by dividing by 180 degrees. You are going to find around 0.6667 something. If you look at the value of R will be equal to 15.8 centimeters. So when you are going to calculate S, you are going to substitute R by 15.8, multiply by the angle theta in radiant, 0.6667, and you are going to find a value of S 10.5 centimeter. Okay? Why do we have to write 3? And let me write this. Okay, I'm good with that. Why do we have to have 3 significant digit? Because if you look at 15.8, 15.8 is a 3 significant digit. I do not count theta. Theta right now is 38.2, but I'm converting theta into radians, so theta becomes an intermediate calculation. Therefore, I need to take all the number that my calculator is going to give it to me. So the reason why I'm sticking 3 significant digit is because we're having 3 significant digits for the value of R. Let's try to do a problem number 2. In this problem number 2, it's all about having a good representation of what we have. So first, let me draw the picture and then I will get back to you. Alright guys, so now we are going to calculate the length of the arc between the two cities, defined by the two cities. And because I know that the angle to have the angle associated to the city A is 38 degrees north, and the angle associated to go to the city B is 15 degrees south, and up to have the angle theta, and that is going to be defined. Let me use another color right here. I'm going to have the angle theta equal 38 plus 15 degrees, and that gives me a value for theta equal 53 degrees. Now I know I will have to convert that value, and so if I'm converting 53 degrees into radian, that is going to be 53 multiplied by pi divided by 180, or it could be multiplied by 2 pi divided by 360, and end up to have a value. I'm not going to calculate this value. What I'm going to do is, when I'm going to calculate S, which is R multiplied by theta, when R equals 3,960 miles, so because R equals 3,960 miles, I end up to have S equal 3,960, multiply, and I'm just going to multiply 53 pi divided by 180, and I end up to have 3,663.097 miles. And obviously, because I have 4 digit significant digit for the value of R, as the calculation of my angle is an intermediate calculation. So I need to take for this intermediate calculation all the numbers, but the value of the radius has 4-digit significant digit. Therefore, I'm supposed to have S is going to be equal to 3,700 miles. 3,700 miles. So guys, now a rope is wound around a drum of radius R equal 0.327 meter. By rotating the drum through an angle of 132.6, I forgot the 0.6, 32.6 degree. Now, if I want to calculate the arc of the length of drum is defined by the angle of 132.6. What I need to do is S equal R multiplied by theta. I need to write theta as 132 degree, 32.6 degree. And I need to convert that into radians, so multiply by pi divided by 180 degree. And I know that R equals 0.327. And now I can do the calculation. 0.3 S equal 0.327 multiplied by 132.6 multiplied by pi divided by 180. I'm going to find a value equal to 0.757 meter, 3 significant digit, because of the 3 significant digit that I have for the value of R. I do not count the intermediate calculation when I'm transforming the angle theta from degree to converting from degree to radian. All right, let's try to focus on the problem number 4. And on problem number 4, we have a small gear of radius 3.6 inches drive a larger gear of radius 5.4. Find the angle the larger gear rotate if the smaller drive gear rotate through 150 degree. Okay, so we have a big gear. Let me erase that and let me start that again. Okay, I'm going to do it by hand. So we have a big gear. Not too bad for doing by hand. And we have a small gear. All right. So when I turn my big gear like this, my small gear will turn in the other side. The idea is, and the key is, the arc length of rotation of the leader gear, the arc length of rotation of the little gear will be equal to the arc length of rotation of the biggest gear, of the big gear. So basically, if I call that the gear number 2 and the gear number 1, if I call, let's call the little gear the gear number 1, and the bigger gear the gear number 2, I can easily say that S1 will be equal to S2. That is 1. So let me put the 1 right here. That is the gear number 1, and the biggest gear is gear number 2. So that means that theta 1 multiplied by the radius of the gear number 1 is equal to theta 2 multiplied by the radius of the gear number 2. I am looking for the value of my angle of number 2 because they are telling me find the angle of the larger gear. So I'm going to express theta 2, and theta 2 is equal to theta 1 multiplied by r1, and I will have to divide by r2, the radius, to have theta 2 standing by itself. 1, I'm able to express theta 2. I know that theta 1 equal 150 degrees. So I will have to multiply by pi and divide by 180 to have this angle in radian. I know the value of R1. R1, the small gear, has a radius of 3.6 inches. And the biggest gear has a radius of 5.4 inches. I'll let you do the calculation. But technically, you are supposed to find a value of theta 2 equal, and I will ask you the questions on Edpuzzle. Now, the area of a sector. The area of the sector is defined with the formula A equal 1/2 of theta multiplied by the square of your radius. So, on the problem number 1, it's going to be pretty easy to calculate the area of the sector intercept by the central angle 38.2 in a circle of radius 15.8. IA is equal 1/2 of theta multiplied by r square, which is going to be 1/2 multiplied by 38.2 in degree multiplied by pi over 80 to transform my theta into radian. And then I multiply by 15.8 square, and that will give me an area equal around 83.219 square centimeter. And if I want to take account the number of significant digits, I'm going to take 3 significant digits, and this is why the area will be equal to 83.2 square centimeter. I'll let you do the next problem. To find the area, what I can tell you is you must find the area for the radius equal to 22.4 inches. Then you must find the area for the radius 11 inches. And then you will be able to subtract these two areas to find the area of the region below. Problem number 3. Oh, by the way, for the perimeter, let me write the perimeter for you. So the perimeter, let's calculate the perimeter. I was forgetting that. 22.4 minus 11 will give me 11.4, and the perimeter is supposed to be equal to 11.4 plus the arc length of the big arc length plus 11.4 plus the arc length of the little radius. And so I end up to have P equal 22.8 plus theta r big plus theta r little. You literally end up to have the perimeter equal 22.8 inches multiplied by theta factor r big plus r little. And when I do the calculation, I end up to find a perimeter of 54 inches. I'll let you work on the problem number 3 and 4 by yourself. I will give you the answers in the questions